Examining relationships. In this program, we'll learn two ways to examine the relationships between variables. We have one method when we are examining the relationship between two quantitative variables. We have a different method that we're going to learn when the variables that we're examining in terms of relationship are categorical. Let's look at the quantitative case first. The method that we're going to learn is called simple linear regression. We're going to learn how to obtain and interpret the estimated regression equation. To measure how well that equation models the relationship between our two variables, we'll use a statistic called R squared. We'll also learn how to obtain and interpret a scatter plot. Moving on, we'll learn how to use a residual plot to check for any regression outliers. In general, the research question that we're considering now that we're relating two variables is what is the effect of the independent variable, or labeled the x variable, on the dependent variable. Let's run a simple linear regression. If our research question were to be, what is the effect of income, which is quantitative, on the dependent variable amount charged, which is also quantitative. So here we're relating two quantitative variables. One is an independent variable and one is a dependent variable. In simpler terms, we're trying to determine whether or not changes in a cardholder's income affect how they spend on the credit card. To use Excel to set up our simple linear regression, we just need to input two variable numbers, one for the independent variable, or IV, and one for the DV. The IV in this case is income, so we would input variable 1. The DV is amount charged, which is variable 3. Next, we click the Worksheet tab, Regression. Here are our results. First of all, our scatter diagram, or also called a scatter plot, shows that there's generally a linear relationship between income on X and amount charged on Y. In other words, as X increases, it appears that Y, the amount charged, increases as well. Simplest terms, the more money you make, the more money you spend on the credit card. What's the equation that can be used to model that relationship? Well, the form of the equation is right here in words. The predicted Y value, or in this case, the predicted amount charged, equals the slope, here 13.4812, times X, which would be a given income, plus the y-intercept, here 2,212 and 47 cents. Using that equation, I could input a particular income, such as 90,000. If X is 90,000, my equation would produce a predicted Y value, in this case a predicted amount charged, of $3,425.78. In other words, the regression equation predicts this amount charged given an income of 90,000. Now that we've obtained the estimated regression equation and the scatter plot, let's look at the quality of our regression. R squared, called the coefficient of determination, tells me what percentage of the change or variability in amount charged can be explained by its relationship to income. Here, r squared is 0.4031. So I could say that 40.3% of the change in amount charged can be explained by a cardholder's income. If I were to click the Worksheet tab Residual, I would see my residual plot, just the lower plot. The residual plot will give me an indication of any large residuals, or what we call outliers for regression. Those outliers for regression are going to have a direct effect on r squared. If there's less residual, in other words, if all of my data points are closer to the regression line, r squared will be closer to 1. If the data points are spread out more around the regression line, then r squared will be closer to 0. So why do we do it? Why do we use simple linear regression? We are looking for the observed effects in our sample data. We're only working with one sample of data at this point. So all we can really conclude is, in our sample, does it appear that an independent variable such as income affects a dependent variable such as the amount charged? Eventually, we'll want to use that observed relationship, our regression equation, as a basis for statistical testing, so that we could answer a much more important question, and that is the observed effect, that is, the observed relationship between income and amount charged, statistically significant? In other words, is it something we would expect to hold for the entire population of cardholders? Now let's look at a case where the variables we're relating are both categorical. Here, the method that we're going to learn is called cross-tabulation, or simply put, we're going to use crosstabs. The crosstabs will show us both joint distributions and conditional distributions. The conditional distribution by independent variable is the most important result when considering the relationship one variable has on another. The clustered bar chart will show me graphically that conditional distribution so that I could report the observed effects using that clustered bar chart and provide the necessary interpretation. So here we are back at our Excel sheet, and now we're going to consider the following research question. What effect, if any, does gender, which is variable 4, have on the amount charged? Now, amount charged, variable 3, is quantitative, but in order for this to work on our crosstab, we need to recode the amount charged into categories. We need to do this because our independent variable gender is categorical. Variable 7, called coded amount, is a recoded version of variable 3. Simply using the first digit, I've created categories separated into thousands. So the 2's all spent in the 2,000 range, the 3's all spent in the 3,000 range, and so forth. To make my Excel tool work, I'll need to specify an independent variable. Here, that's variable 4, gender. As always, because gender is categorical, I need to tell Excel those category labels. The dependent variable here is amount charged. Variable 7 is the correct form of that dependent variable, and I very simply have 5 categories of amount. If I click the Worksheet tab Crosstab, I can see the results. The top table is the actual crosstab. The second table, called Joint Distribution, tells me the percentage of each cross count. In other words, 18 of the 18 cardholders in our sample are women and spent in category 3. 18 out of 77 is 23.38%, part of our joint distribution. The joint distributions are helpful, but they're not very helpful in understanding the effect that gender has on spending category. The conditional distribution by independent variable is the most important result of my crosstab in terms of examining relationships. Here we see if a cardholder is a man, we see the percent distribution of spending category. If a cardholder is a woman, we see the same conditional distribution of spending category. The difference between the men and the women is the effect of gender on spending. Here we could see that our percentages are quite different for each spending category. We could also see that visually on the clustered bar graph. Here the women are in red and the men are in blue. The differences show us an observed effect in our sample data of gender on spending category. So why do we use the cross-tabulation? We're working again with one sample of data. So descriptively, we can show or describe the observed effects of one variable on another. We don't know if the relationship that we observe in the sample data is statistically significant. In other words, we don't know if the observed relationship will hold throughout the entire population of cardholders. The descriptive analysis of the relationship, in other words, noting the observed effect, gives us a basis for statistical testing. Later in the course, we'll learn how to run a test to determine if the relationships that we observe are statistically significant. Now let's briefly review both methods that we just covered. First, the simple linear regression method. We're using this method to examine the relationship between two quantitative variables. One is an independent variable and one is a dependent variable. When running our regression, we're going to report the following: the scatter plot, the regression equation, r squared, and we'll do a quick check of the residual plot. When we relate two categorical variables, we use the crosstab. No matter what the form of the variables when we start, we have to recode the variables categorically in order for them to work on a crosstab. Once we get our crosstab set up, Excel will produce for us the conditional distribution by independent variable, as well as the clustered bar chart. And we would have to report both of those when reporting on the observed relationship between two variables. As always, when we include our output in our report, we would include also the appropriate interpretation and explanation of the results. This is something we'll practice much more in class. This concludes the program Examining Relationships. This is the final program of Unit 1. Unit 2 begins with the program Normal Probability.